This is a rational inequality. 3 over x minus 2 is less than 1 over x. I have to solve it. First thing is I will get everything onto one side of the less than. 3 over x minus 2. I'm subtracting 1 over x from both sides is less than 0. Now I will find a common denominator, which is x times x minus 2. X times, x minus 2. So it's still going to be less than 0. Here the x minus 2 cancels out. 3 times x, 3x. And then the x's cancel out here. Minus x minus 2, which is negative x, and negative times negative 2 is plus 2. Negative x plus 2. And then, of course, divided by the common denominator, x times x minus 2. 3x minus x is 2x, so this is 2x plus 2 divided by x times x minus 2 is less than 0. Now I'm going to find critical points by setting the top and bottom equal to 0. That is, my hero 0, such a funny little hero, until you came along. We counted on our fingers and toes, now you're here to stay. And nobody really knows how wonderful you are. Why we could never reach the stars without you, 0, my hero. How wonderful you are. That was a musical interlude, but I'm setting the top and bottom equal to 0 to find the critical points. 2x plus 2 equals 0. That means 2x, I'll subtract 2 from both sides, equals negative 2, and x equals negative 1. That's one critical point. And then this, I can use a zero product rule. X equals 0, x minus 2 equals 0. So x equals 0. X minus 2 equals 0. I add 2 to both sides. X equals 2. So there are my critical points. Negative 1, 0, and 2. So now I will use those critical points. I'll do negative infinity to negative 1. Negative 1 to 0, 0 to 2, and 2 to infinity. Now, infinity is always curvy brackets, and all these other ones are curvy brackets. I could show it can't equal 2 because 2 minus 2 is 0, and 0 times anything is 0. Division by 0 can't do it. And let's see, is there any other one? Yeah, 0, it can't equal 0. Because if I put 0 here, 0 times 0 minus 2 is 0 in the denominator. Can't be. But, okay, so I know it can't be those. And it's not going to be negative 1. Let's see. I'll plug, just to prove it, I'll plug negative 1. 2 times negative 1 is negative 2, plus 2 is 0. That's 0 in the numerator. That makes it equal to 0. The bottom is negative 1 times negative 1 minus 2. Negative 1 times negative 3 is 3. 0 over 3 is 0. 0 is not less than 0. So, again, I knew that because this is just less than, not less than or equal to, these are all not including the boundaries. But now I just have to pick numbers in there, and I will check it with 2x plus 2. 2 times x plus 2. Or no, it's not 2 times x plus 2. It's just 2x plus 2. It literally is 2x plus 2 over x times x minus 2, and I'll make sure it's less than 0. All right, this one I'll use negative 10. This one I'll use negative 0.5. This one I'll use 1. And this one I'll use 10. And I'll see which intervals are included. So negative 10. 2 times negative 10 is negative 20. Plus 2 is negative 18. Divided by negative 10 times negative 10 minus 2. Negative 10 times negative 12 is 120. That is, in fact, negative. So that interval is included. Let me try this one, negative 0.5. 2 times negative 0.5 is negative 1, plus 2 is 1, divided by negative 0.5 times negative 0.5 minus 2 times negative 2.5. Negative times negative is a positive, so this is 1 over a positive. Positive over positive is positive. That is not included in the solution. It's got to be negative, not positive. I'll try 1. 2 times 1 is 2, plus 2 is 3. 1 times 1 minus 2 is 1 times negative 1 is negative 1. That is, in fact, negative, so that's included. And let me try 10 now. 2 times 10 is 20, plus 2 is 22. 10 times 10 minus 2 is 8 is 80. 22 over 80 is positive, not included in the solution. So the solution is negative infinity to negative 1 union with 0 to 2. And I think if you do this one on Desmos, I think it's going to show this one as included, but it's not included. So anyway, that's your answer to this rational inequality. Any number from negative infinity to negative 1, and then any number from 0 to 2, not inclusive of those.